the dot product may result in a negative number. So that number can be negative. What does that mean? Is it something meaningful, potentially? Well, what does it mean that this number is negative? Can the magnitude be negative? Well, the cosine can be negative. Right? What does it mean that cosine is negative?
The direction of the force is opposite of what you assume it to be.
Exactly. It means that the angle is greater than 90 degrees. And that means that the vectors v and u have almost opposite directions. And geometrically, that means that the useful component of u doesn't actually push the object, it pulls it back. So in that case, this computation will tell us that what we are doing is slowing down the object if we want to move it in that direction. And that will be done purely algebraically without any necessity of drawing a picture. Okay? Someone gives you two vectors algebraically, you will figure out the effect algebraically. And there is no need to imagine how the vectors look like. And that will be especially useful in 3 dimensions when drawing two 3-dimensional vectors and figuring out how they act with respect to each other is, well, sometimes a problem. So, so that's the first and probably primary use of the concept of the component. Figuring out whether two vectors look in roughly the same direction or in the opposite direction. And that is basically a part of the meaning of the dot product. The dot product is going to be 0 if the two vectors are perpendicular. The dot product is positive if the vectors are roughly looking in the same direction. If the angle between them is less than 90, making the cosine positive. And the dot product is negative if the vectors are looking roughly opposite directions, making the cosine negative. So that's what dot product tells you very quickly.